Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to talk about something that's really out of this world, the threat of an asteroid impact from outer space. You know, the dinosaurs did not have a space program. They didn't know what hit them 65 million years ago when that asteroid or comet, perhaps no more than 6 miles across, plowed into the Yucatan of Mexico, wiping out the dinosaurs. But with us today is Dr. Edward Lu. He's a NASA astronaut with 3 missions in outer space under his belt. He spent 206 days in outer space, and he's one of the founders of the B612 Foundation, a foundation that's dedicated to alerting the world about the potential dangers of an asteroid impact. So once again, with us today is Dr. Edward Lu, one of the founders of the B612 Foundation and the Asteroid Institute, with 3 missions in outer space under his belt, talking today about the risk of an asteroid impact. So, Edward, glad you could be on Science Fantastic.
Thanks, Michio. It's great to be on.
First of all, tell us, what is the B612 Foundation, and what does B612 stand for?
Well, the B612 Foundation is a nonprofit that is dedicated to protecting the Earth from asteroid impact. The origin of the term actually comes from the book The Little Prince. I'm not sure if you've read that, but it was a favorite book of mine when I was a kid. It was written by renowned French author Antoine Saint-Exupéry. And the story is about a little boy who ends up on Earth, but the little boy actually had an asteroid home, and that was called B612. And so that's where we took the name for our nonprofit foundation.
Okay, and what are some of the goals of the B612 Foundation?
Well, our main goal really is to map the inner solar system. And I'll explain why that's important. It's important because the future of humanity, as you say, lies not just on this Earth, but throughout our solar system at least. And if you look at the things it takes to open up a new frontier, the first thing you have to do is you have to map it. And that's true for a number of reasons. First, as with any new frontier, you have to map it because you need to know how to defend yourself. The second reason is you want to know where all the resources are so that you can spread outward and take advantage of those. And third, of course, is for science, curiosity. So for instance, when the United States bought the Northwest Territories, first thing we did is we sent Lewis and Clark out there for exactly these reasons. Or in the 1500s, the British, the Spanish, the Dutch, they sent ships around the world to map the world for exactly this reason. And here we are today with the next great frontier is the inner solar system. The reasons we would go out there to map the locations of these asteroids is, number one, to protect the Earth from being hit by them, because if you don't know where they are, you don't know how to protect from being hit by one, because you don't want to know when the next one is coming. Number two, they're the locations of resources, primarily water, which can be used to make rocket fuel, which would be used to travel around the solar system, and of course, for science, because it tells us about the formation and history of our own solar system. So for all those reasons, we need to map the locations and trajectories of all these asteroids. It's a little different than the kind of map you might think of, which might be something you can put on your desk that's flat. In this case, the solar system is three-dimensional, and most importantly, everything's moving. Things are in orbit around the sun, different orbits, and you actually have to track where they're going, not just where they are at any given time. So it's
okay, now, right. Now, Carl Sagan once said that if you could somehow illuminate all the asteroids in outer space that are near the planet Earth, then you would be shocked, absolutely shocked to see this ocean of rock that the Earth is swimming in. And you begin to realize that there are thousands, tens of thousands of pieces of debris out there. any one of which could create a disaster if it hit the Earth. So do you think, therefore, that the danger of an impact with an asteroid is much greater than the average person thinks?
Well, it certainly is. In fact, it was an understatement to call it tens of thousands, because there are millions of asteroids out there which circle the sun in orbits that could hit the Earth, or that regularly come close to the Earth, in fact. And so I don't know if most people realize it, but these things do hit the Earth on occasion, and all the time they come close to the Earth. For instance, just in 2013, we had an asteroid, a small one, just 20 meters across, so the size of a small building, explode in the skies above the Russian city of Chelyabinsk. It had about 30 times the explosive energy of the bomb dropped over Hiroshima. So just about half a megaton of TNT, explosive equivalent. It was an enormous explosion, 30 times larger than the atomic bomb. Luckily, it was actually not that close. The city was far above it, and it was moving away from the city when it exploded. So it only injured a few thousand people, only destroyed a few 100,000 windows, and only damaged about 7,000 buildings.
And I understand that back in 1908 in Tunguska, Russia, there was an even bigger impact with an asteroid or comet from outer space, and it created a considerable amount of damage. And if it had hit a city, it would have flattened the entire city. Could you elaborate?
Yes. In 1908, on June 30th, there was an explosion over, luckily, a empty area of forest in an area called Tunguska. And if you go out there and look at the area of destruction, because what it did was it essentially blew down the forest. The shock wave.
Okay, Edward, we have to take a short commercial break, but after the break, we're going to continue a discussion of danger from outer space. What happens if one day we get hit by a killer asteroid from space? Science Fantastic with Professor Michio Kaku. Once again, on the line we have with us Dr. Edward Lu, one of the co-founders of the B612 Foundation and Asteroid Institute. He's had three missions in outer space, a total of 206 days in outer space. And we're talking about the potential impact of a giant killer asteroid or comet from outer space. Well, Edward, where we last left off, we were talking about killer asteroid impacts that hit Russia. We had one in 2013 and another one back in 1908. Asteroids about the size of an apartment building plowing into Russia. These are called city busters, objects that are capable of taking out an entire city. And the question is, how often are these asteroids? Some people say that perhaps as often as once every 100 years. Most of them land in the oceans. We don't even know about them. But tell us how frequent some of these impacts are.
Well, that's about right. The one that hit in Chelyabinsk, 20 meters across, the size of, about 30 atomic bombs. Those hit the Earth about every few decades, maybe every 50 to 100 years. And ones like Tunguska, a little bit larger, would take out a city the size of, say, London or New York. If it were to hit, those hit the Earth perhaps every 300 to every 1,000 years. So not that common, but enough that it does sometimes happen. And again, I should point out that those things, they have to hit a city for them to destroy a city. And as you rightly point out, most of the time, most of the Earth is actually uninhabited. It's ocean.
Right. Now, I understand there's yet another asteroid out there called Apophis. It is about 1,000 feet across, much larger than a simple apartment building, and it would cause considerable amount of damage, perhaps able to take out most of England if it were to hit a nation. And it's going to make not one, but two trips very close to the Earth. So could you explain to us the danger of an object like Apophis, which is about 1,000 feet across, which is going to come whizzing by the Earth in the next years?
Well, luckily, we happen to be able to track Apophis extremely accurately. And we know for a fact that this is not going to hit us. It's actually going to come very close, and we know how close it's going to come. So that one is really an opportunity to watch an asteroid do some great science as it comes close to Earth in 2029 and 2036. So that one's really more of an opportunity. It's going to come extremely close to Earth. And when I say extremely close, I mean it's coming underneath our geostationary satellite.
Okay, and it's going to make not one pass, but two passes, right? In 2029, I think in 2036?
Exactly. In fact, that's the common thing. When asteroids come close to the Earth, they come close to the Earth in general many, many times. And that's because when an orbit is really, you can think of it as like a repeating racetrack pattern. And if the Earth's orbit and its orbit have an intersection point, what makes a collision is when the Earth and the asteroid are there at the same time. It's a matter of timing. But otherwise, they just keep repeating around their pattern. So if an asteroid comes close to Earth, it tends to come close to the Earth a lot of time.
Okay, so we talked about city busters.
Example, yeah. Mm-hmm.
Right. And then we talked about, well, nation busters, Apophis at the level of being able to take out a small country like England. But then we have, of course, the planet busters like what hit Mexico 65 million years ago. So tell us a little bit about how did this killer asteroid or comet wipe out the dinosaurs when it impacted into the Yucatan of Mexico 65 million years ago? Walk through the steps.
Yeah, that was a very rare event. But again, these things do happen. Things that large that could really affect the ecosystem of the entire Earth happen on this time scale of millions of years, so quite rare. And what actually happens is they throw up enough molten rock into outer space, which then rains down all over the Earth, heating the atmosphere. And what that does is basically sets fires all around the Earth. And so the dinosaur-killing asteroid 65 million years ago, it actually set off a global firestorm within the first day. So that global firestorm basically burned everything worldwide and resulted in enough soot and ash in the air, in the upper atmosphere, to leave the Earth dark for years afterward. And that killed off the dinosaurs and most species alive at the time.
Now, some people theorize that the dinosaurs died because, well, they were cold-blooded. Things got really cold, and they were unable to adjust to the fact that sunlight was being darkened by all these clouds of smoke. But our ancestors were furry little mammals that are warm-blooded, and our body temperature could remain 98.6 degrees even when it's chilly outside. So some people think that we survived that impact because we were warm-blooded rather than perhaps cold-blooded. But what are your thoughts?
I'm not so sure about that. I think really it was a matter of the larger animals died because if you think about the entire food chain collapsing due to basically everything burning worldwide, the things that are most vulnerable are the larger animals. The things that can get by are things like cockroaches, rats, tiny little things that can live in hide away in little places and find sources of food. The big things, they starve.
Okay, now let's talk about Hollywood for a second. Hollywood has movies like Deep Impact and Armageddon, where we have Bruce Willis saving the population of the Earth by riding on the space shuttle. Well, the space shuttle's been canceled, and the space shuttle cannot even reach deep space to begin with. All it can do is orbit around the Earth.
We only orbit the Earth with that.
Right. So instead of spinning wheels around the Earth, some people say that we should, deflect or blow up these asteroids if they're coming close to Earth. But there are dangers in that, too. So give us the pros and cons of what we're going to do when we do detect an asteroid with our name on it.
Well, first off, over the next few years, we're going to be developing the technology to more easily visit, and I believe someday actually make use of resources on asteroids. There's a huge opportunity to finding out where these things are, far bigger than any of the terrestrial opportunities out there, I believe, someday. I don't know when this is going to be. Now, the same kind of technology is the kind of thing you would use to deflect an asteroid because, in general, you're going to find these things if you do a good job of mapping the solar system, in general, you're not going to find these things like weeks or days before they hit the Earth, but you're going to find them 10, 20, 30, 50, 100 years before they hit the Earth. And then you have time to easily make a tiny nudge on these things and make them miss the Earth. And that's a process could be as very simple, just simply running a small spacecraft, just running it into the surface of it and deflecting. Again, if you do that decades beforehand, that's all it takes.
Now, do we really have the technology? I mean, has this been tested? We're talking about deep space missions now, missions that are way out there, not just circling the planet Earth. But do we have any trial run? Do we have any expertise? Because, of course, the fate of the Earth and civilization depends upon getting it right the first time. So what has been Yeah,
it turns out actually that it's easier to run an asteroid into something than it is to pull up next to it and do a scientific mission, because then you have to match speeds with it. Otherwise, just like driving a car, it's easier to hit something than to drive next to it in a race, right? And so we've actually run a probe into a comet more than 10 years ago, a mission called Deep Impact, and in order to create a crater and to study the what's below the surface. But that mission actually did deflect the comet by a small amount. And in the upcoming years, we're going to be testing a mission called DART, which is actually going to test this on an asteroid and measure very accurately the effect of the deflection that we give it. Because we're going to pick what's called a binary asteroid. It's two asteroids actually orbiting around each other in a little pair, kind of like the Earth and the Moon system. But if you deflect one of them, you can determine exactly how much you deflected it by, because its orbital period around the other asteroid will change slightly.
Also, tell us a little bit about the Sentinel Space Telescope. Let's take a short commercial break, but after the break, let's talk about space telescopes that can lock onto these objects before they hit the Earth. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Our special guest is a former astronaut, founder of the B612 Foundation, alerting us to the dangers of asteroid impacts from outer space. Fantastic with Professor Michio Kaku. Once again, if you want to be part of the dialogue, then give us a call. The hotline number is 612-564-8135. You'll get a recording. Leave your name, call letters of the radio station you're listening to, and the city you're listening from, and perhaps you can get on Science Fantastic. And once again, also, I'd like to thank everyone out there. My latest book, The Future of Humanity, hit the New York Times bestseller list, and it talks about a future perhaps in outer space. We need an insurance policy, said Carl Sagan, just in case of an asteroid impact or supervolcano or another ice age, or, well, the sun is going to eat up the Earth in 5 billion years. So in any event, we have to leave the Earth at some point in the future. Well, with us today to talk about this is Dr. Edward Lu, one of the founders of the B612 Foundation. And we'd also like to dedicate this show to the memory of Dr. Stephen Hawking, the great physicist who also alerted the people of the world to these cosmic dangers. He said, yes, our future does lie eventually in outer space because of the potential of self-inflicted wounds like the greenhouse effect or nuclear warfare, or Mother Nature. Even though we think of Mother Nature as being warm and cuddly, sometimes Mother Nature can be indifferent and wipe out species on the planet Earth. It's sobering to realize that 99.9% of all species that have ever lived went extinct. If you don't believe me, drill underneath your feet. If you simply drill right underneath your feet right now, you'll encounter the bones of the 99.9% of species that never made it. So extinction is the norm. But even though the dinosaurs did not have a space program, we do. We do have a space program. And with us today is Dr. Edward Lu to talk about what we can do about the threat of asteroid impacts. So let's talk about the Sentinel Space Telescope. That's one of the projects of the B612 Foundation. So you think, therefore, that a space telescope would be the first line of defense?
Well, Sure. First off, the Sentinel Space Telescope is a project that we have canceled years ago. It was something that we were working on in order to find and track asteroids, but the need for it was somewhat superseded by two things. Number one, NASA's trying to build its own version of it, and they're putting significant money into that. And number two, the National Science Foundation, together with the Department of Energy, have invested in the world's largest asteroid finding telescope, which is under construction right now. It's almost a $700 million project being built in Chile called the Large Synoptic Survey Telescope. And the combination of these two means that we felt that it didn't make sense for us to push forward with the Sentinel project. What we realized is that these two telescopes will actually find the great majority of the larger asteroids, the ones large enough to take out a country, as you say. But the much more frequent smaller asteroids, ones like Tunguska, the ones that are actually come close to the Earth quite often, these types of asteroids will still be missed by the two aforementioned telescopes. And so we're working on a new technology to find and track these ones. And we think the way to do that is using smaller telescopes with modern computing that allows them to stare at a position for a very long period of time and to cancel out the motion of the asteroids, which are actually too dim to be seen at any given time. And if you have fast enough computation, you can actually do that.
Okay, let's do a thought experiment. Let's say that we're in a Hollywood movie. Let's say that our telescopes do detect an object, a big one, barreling toward the Earth, and we have, maybe a year's warning. What are we going to do? Call the Joint Chiefs of Staff? Fire up our nuclear weapons?
Well, first off, the scenario you mentioned is the kind of thing that happens only in Hollywood movies. It's like, what am I going to do if zombies show up at my door? Well, it doesn't happen in real life. What's going to happen is we're going to say, we're going to take careful measurements of an asteroid, and 55 years from now, some asteroid has a chance of hitting Earth. We will send some small probes up towards it, measure it carefully, and then we will send satellites to just run into it and change its trajectory ever so slightly in a controlled fashion to keep it from hitting the Earth. In reality, that's what would happen. What happens in the Hollywood movies is just for entertainment purposes, and they're fun, but they don't have any relation to reality.
Now, what about the idea of using hydrogen warheads to blow up or even push and deflect an asteroid? Will that make the problem worse or better?
Well, I mean, if we were to find something extraordinarily rare and we got extraordinarily unlucky, that nightmare scenario, again, extraordinarily unlikely, is something that people have suggested that you could, as a last resort, use our nuclear weapons to deflect an asteroid. It is possible. What you would have to do is to actually detonate the weapon off the surface of the asteroid. The idea being not to break it up, but to nudge it. And this tremendous amount of energy would actually essentially evaporate some of the rock, or heat it up enough so that it blows it off the surface, which has the effect of pushing some.
Okay, well,
it's sort of a last-ditch effort. If all else fails and nothing else can work at that late date, and if the asteroid is that large, so you're piling on unlikely on top of unlikely.
Okay, well, talking about the unlikely, I once had an astronomer on the airwaves, and I asked him to postulate the worst possible case. Again, not the most likely case, but the worst possible case. And he said the following: if you have a comet, a virgin comet, a comet with no tail, because it hasn't made its first pass around the sun yet, covered with soot, no tail, and it's a long period comet, so it's not periodic. We don't know its trajectory. We haven't seen it come close to our solar system ever. It makes a first pass behind the sun. Therefore, our telescopes are blocked because it is passing around the sun with no tail. When it comes around the sun, it has a tail, and then it's headed directly for the Earth. How much warning? Well, a month or so, he said.
Yeah, maybe a month.
So even though that is highly unlikely, is it even physically possible to have a long-period comet with no tail, no trajectory that's been cataloged by any computer or any telescope, sneak up behind the sun?
Sure. If you want to piece together an unlikely scenario, that you can. But I don't think that's a great reason to spend your thought cycles and so much on these kind of truly rare cases. The things we should be thinking about really is, again, more not the danger of these things, but the opportunity involved. And if you can take advantage of that, you automatically solve the asteroid issue.
Okay. Well, now let's flip it the other way and talk about the most likely possibility. We're going to take a short commercial break. And after the break, we'll talk about the more likely possibility of what could happen if a small object endangers the planet Earth. To Science Fantastic with Professor Michio Kaku. In this hour, we're talking about a threat to the planet Earth. It happened before. 65 million years ago, the dinosaurs, well, they didn't have a space program, and they're not here to talk about it. Precisely because most life forms on the planet Earth eventually go extinct. 99.9%, and that's a modest estimate, of all life forms on the Earth eventually go extinct. Now, we don't want to go that way. We have a big brain. We can plot. We can scheme. We can devise plans. And with us today to talk about some of these plans is Dr. Edward Lu. He's one of the founders of the B612 Foundation and Asteroid Institute. He's had 3 missions in outer space, and he's had 206 days in outer space. So, Edward, we were last talking about, first of all, the most unlikely but possible scenario of a comet catching us off guard as it goes around the sun, so our telescopes cannot even detect it. But now let's talk about more of the garden variety threat.
Yeah,
you talked about being able...
1 million times more likely.
Right.
Or 100 million times more likely.
Right. Let's talk about that one now. And you talk about the fact that an object the size of a football field, well, we're beginning to get good at looking at those objects. But what about smaller objects? An object maybe half the size or a third the size of a football field, they can do a considerable amount of damage. They're bigger than an ordinary apartment building. They can slam into a city and cause tremendous damage. What about the likelihood of one of those things? And what do we do if we detect one of these things?
Yeah, again, this is the kind of thing that would confront us perhaps every few hundred years. But what actually happens is that to begin with, you measure their orbits, but you don't know it exactly because there's always some uncertainty in your measurements. And what you have to do actually is calculate a probability that this thing is going to hit the Earth. And when you find an asteroid that's coming close to the Earth that has a chance of hitting the Earth, we have to take more and more measurements over a period of years in general to see for sure if they're going to hit. So that process can take years, where we're trying to decide how likely is a particular asteroid of hitting the Earth. And what will happen is actually, if that thing is going to hit the Earth for real, its probability that we measure will climb as we realize our measurements are better and better, get better and better. And eventually you'll get to the point where you can't take it anymore, and you say, okay, well, we need to start planning for a mission to move this one. And then hopefully at least a decade before this thing hits, at that point, you're launching probably 1 or 2 missions to deflect it, to give it a tiny nudge and keep it from hitting the Earth. I actually think this kind of thing is going to happen to us in our lifetime. This scenario is going to play out, and it's going to actually be a big deal because for the first time, human beings will have changed the if you like, the evolution of the solar system, the dynamical evolution of the solar system, to keep the third planet from being hit by a large asteroid. I think that's going to be amazing. We're going to see that, I believe, sometime in our lifetime.
Now, I get some emails from people that say that, well, aren't we witnessing an increase in the frequency of supervolcanoes and earthquakes and meteor impacts and things like that? And I tell them that, well, it appears that way, but then again, the population of the Earth has expanded. We are now populating areas that weren't populated during biblical times. And as a consequence, the sheer probability of humans interacting with supervolcanoes tornadoes and gigantic earthquakes is much higher. Not because of the frequency has changed, but simply because we're now expanding, our population is growing, and we're expanding areas that weren't explored before. What are your thoughts?
Sure, and to add to that, with modern communications, you hear about things that happen on the other side of the globe. Remember that in the old days, someone had to walk from the other side of the earth to where you are to tell you about it. You as you rightly point out, there are many more people today, and communications make it such that you hear about these things much more often. I don't know that they're actually happening more frequently.
Okay. Now, let me ask you about another thing that we've had on our airwaves, and that is asteroid mining. Google billionaires are putting their money on the line to sponsor programs with planetary resources to mine the asteroids. And, of course, before you can mine the asteroids, you have to know where they are, what they're made of, and things like that. But how do you find that parallel development? They, of course, would also have to locate these things and assess their nature, composition, and things like that. But what about those people who see a gold mine, a gold rush in outer space if we can mine the asteroids? What are your thoughts?
Well, I think someday, and here again we're talking, perhaps hundreds of years out, where human beings regularly travel throughout the solar system because there are other colonies and other locations, perhaps Mars. And a very, very good place to obtain rocket fuel is from asteroids. And rocket fuel is just water because the constituent components are hydrogen and oxygen. And these, if you like, floating gas stations are all over the solar system. They're asteroids.
And some people think that if you look at the next century, that precisely because asteroids have some water and chemicals on them, they can become space stations, ready-made space stations, gas stations, in fact, if we can find enough organic materials and hydrogen-based chemicals in them, that they could be a resource, that we should study these things, not just because they propose a danger, but because eventually they could be platforms for further exploration into space. What are your thoughts?
I think that's exactly right. That's the reason why we at the B612 Foundation, the Asteroid Institute, are working to map the locations and trajectories of these asteroids because, again, it will someday enable, we believe, expansion out into space because of resources. It's a great driver of science. And, of course, you help protect the planet from asteroid impact.
Okay. Well, unfortunately, we have run out of time in this segment of Science Fantastic. Once again, our special guest today was Dr. Edward Lu. He got his Ph.D. from Stanford, had 3 missions in outer space, spent 206 days in outer space, and the B612 Foundation is dedicated to helping to protect the Earth against a potential asteroid or comet impact. Once again, this is Science Fantastic with Professor Michio Kaku.